Okay, so let's take a look at this. Now I know many of you have it done, but I want you to listen to what I'm thinking in my head, which I'm going to say out loud, of course, so that you can think, oh, you know what? Yep, I'm good. Or maybe you'll be thinking, oh, you know what? I like the way Miss Weinreb sort of thought that through. I'm going to try to do that next time. Okay? So here we have factored form, clearly. So my zeros are going to be what makes this bracket 0 and this bracket 0. So my zeros, which is the same thing as x-intercepts, will be, well, 5 minus 5 is 0, and negative 9 plus 9 is 0. So what's an easy mistake to do? Forget the negative. Be careful. Here's the thing. Some of you are thinking, that's not a mistake I make. Some of you are thinking, I make that mistake all the time. Everyone's different. You have to just know where you make mistakes so you can pay attention. So the direction of opening, that's positive, so it's up. The axis of symmetry is x equals the x value of the vertex. Well, hang on a second. What is the vertex? Well, what is the x value of the vertex? Well, this is 5 and this is negative 9. So we know if this is a number line and this is negative 9 and this is 5 and this is 0, from here to here is 5 spaces and from here to here is 9 spaces for a total of 14 spaces in between them. And half of 14, or halfway in between here, is 7. So 7 from here, or 7 from here, is what is going to be the x value of the vertex and the axis of symmetry. So 7 from negative 9 is negative 2. You could have done it from here. 5 and 2 more is also 7. So negative 2. Then our step pattern is here. It's going to be over 1 up 2, over 1 up 6. And we also know that our vertex has an x value of negative 2 and a y value of, well, I don't know, let's figure it out. So the y value is going to be, well, this is what y is equal to. And then we have to replace x with negative 2, so that's 2. What's negative 2 and negative 5? That's negative 7. And this is negative 2 plus 9 is positive 7. So we have 7 times 7 is 49, and 49 doubled is 98. And then we have a positive times a positive is a negative. So negative 98 is our vertex. That's how you do that. That's how you do that kind of question. Now let's take a look at how to do this with vertex form. So with vertex form, we know that our zeros are where y equals 0, what are the x values. So it's not so simple like it is here. We have to work this through. So I'm just going to do some work over here. So I've got y equals 0. Well, when y equals 0, we have 0 equaling negative x plus 2. Negative is outside the bracket, squared plus 6. So I'm going to bring this over to the other side. So negative, all of this becomes positive, all of this, equals 6. And then now I need to take the square root of both sides. So if I take the square root of both sides, that's plus and minus root 6. And then I have to bring negative x plus 2 here over here, so it'll be minus 2 plus or minus root 6. So if I want that as the nearest whole number, I will be letting you use a calculator, obviously. I think by now you know what I think is reasonable for calculator use and what I think is reasonable for mental math, right? Like 6 times 2, you should be able to do that in your head faster than you can press the buttons on a calculator. Minus 2 plus root 6, I'm thinking that's looking like a calculator thing, right? Okay, and remember there's really two things here. There's minus 2 plus root 6 and minus 2 minus root 6. So those are going to be here. I'm just going to write x equals plus, x equals minus 2 plus or minus the root of 6 as my two zeros. The direction of opening is down because that's negative, so down. Then I've got the axis of symmetry is x equals the x value of the vertex. So what is the x value of the vertex? It's negative 2. Or whatever makes that 0, or the opposite of this. Whatever makes this bracket 0, or whatever the opposite of positive 2 is. The step pattern will be over 1, down 1, over 1, down 3, because there's a negative 1 there. And then the vertex, I don't have to figure it out like I did here, because it's in vertex form, is negative 2, positive 6. So the vertex is negative 2, 6. So that's how you do all of this, write up all this information when given vertex form. Okay, do you guys want to do this word problem together? Make sure you guys did it right? Okay. So a cannonball is shot into the air. I guess this is a history book because we don't use cannonballs anymore in the war times. A cannonball is shot into the air. Its height can be described by the equation h equals blah, 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 where h is height in feet and t is time in seconds. Don't forget, you're allowed to write all over this stuff. So you make sure that things are highlighted for you. What are the zeros of this relation? So they're going to be t equaling 1 and t equaling 9. Then we have, what do zeros mean in this situation? Well, zeros are where height equals 0. So when height is 0, and that means the cannonball is 0 feet above the ground, isn't that where the cannonball is? Tell me. If the cannonball is 0 meters above the ground, where is the cannonball? On the ground, right? Right? Okay, so where is it on the ground? Obviously, if you think this through, where this is time and this is height, you know, sorry, my hand's making a shadow, you know that the cannonball will be, which is why you're not surprised there's a negative here, because you know the cannonball is going to be going like this, and then like that, because it goes up and then gravity, force makes it go up, then it starts to peak as gravity pulls, slows it down and then pulls it down faster. So the zeros in the situation are where the cannonball is on the ground. So let's write that down, where the cannonball is on the ground. What is the axis of symmetry and what does it represent? So the axis of symmetry is a vertical line that goes through the vertex, correct? So what is the axis of symmetry? First, the axis of symmetry is a vertical line through the vertex. Now, when you think about a vertical line through the vertex, it's kind of a line that cuts the graph in half, isn't it? Because like what's on the right and what's on the left are reflected onto each other. Now, what else did it say? And what does it represent? Well, doesn't it represent a couple things it could represent? One is, as we just said, it represents a mirror from the two sides of the curve. It also is highlighting the highest maximum point on the curve, isn't it? Okay, so I think that that's what we should write. In this, although in this question, because we're applying it to cannonballs, maybe what we could say is it's, what do you think? It's where the cannonball is highest. Okay, so it's where the cannonball, it highlights where the cannonball is the highest. So let me write this in a sentence. The axis of symmetry highlights the highest the cannonball goes. Now, use the axis of symmetry to find the vertex. Okay, well, we know that the axis of symmetry is the x value of the vertex. And in this case, what is the axis of symmetry if our zeros are 1 and 9? It's halfway in between, or 5. So the axis of symmetry is t equals 5, because we're working with t and h here. And the vertex is, well, h equals -3 t minus 1 times t minus 9, and t is 5. So 5 minus 1 is 4, and 5 minus 9, actually let me write it out. I'm skipping a step because I'm running out of space, but I'll just write smaller. 5 minus 1 and 5 minus 9. So now I have -3, which is 5 minus 1 is 4, and 5 minus 9 is -4, and I've got equals. Negative times positive times negative is that positive or negative? Negative times positive times negative. Positive. And 3 times 4 is 12. And what's 12 times 4? 48. And so the vertex then is 5, 48, right? So, use the axis of symmetry to find the vertex. Done. Next, explain what the vertex means for the cannonball. Well, it tells us the highest height, and what's that tell us? What's the 5 tell us? Yeah, the time when, when the highest height happened. So let's write that up. So I'm writing up, this tells us the highest height and when that happens or occurs, whatever you like. Ta-da! Okay, so now we've done a question like that.